This video talks about graphing logarithmic and exponential functions. Remember, these types of functions are inverses of each other. So they have a lot in common, but it's kind of opposite in common. So let's start with some log functions. So remember that logarithmic functions are going to have a vertical asymptote. So it's really the first thing that you need to identify. So when I am identifying that vertical asymptote, I'm looking with the x. So if there's going to be anything besides 0, you're going to see a set of parentheses, and the number right here will be the opposite of your asymptote. So on this one, it's just 0. So I'm going to start by drawing in my vertical asymptote at 0. So I represent that using a dotted line. And then I'm going to try to be smart with the points that I plot. And so the first one I'm going to plot is 3, 1, and then 9, 2, and then 1, 0. And then they start to get closer and closer to this asymptote, so I'm just going to show that. Now, if you're not sure how to get those points, I just knew that if I plugged in 3, I'd get 1. If I plugged in 9, I would get 2. However, remember, you can also use your calculator, the y equals button, and then go to math, log base, which it's faster if you scroll up to get to that. And then you just type in your base and your x. And then second graph will give you that table that will plot points. And you'll see that the first point you'll see on there is 1, 0, because the rest of them are to the left of that asymptote. Now, if we were stating the domain and range on this, the domain would be from 0 to infinity, because it can't go to the left of 0. That's why we use those parentheses to show that it gets really, really close to 0, but it doesn't touch it. And the range would be all real numbers, negative infinity to positive infinity. And our asymptote, which I'll put it up here because I ran out of room, would be x equals 0. Okay, so on this next logarithmic function, we notice that this one will have an asymptote other than 0. We see this plus 1, which means that it's going to have a vertical asymptote at -1. I'm not doing a great job drawing that, I apologize. And so then we have our asymptote in there. Now we're just going to plot points. So I'm going to start with the point 0, -3. And then 1, -2.5, 3, -2, 7, -1.5. I'm getting a basic shape of this. I don't want to have to plot every one of those points, so that's why I'm not. And then 15, -1 was a point on this as well, but I'm not going to worry about that. I'm just going to make that go out real gradually, get really close to this asymptote here. And if you hit graph on your calculator, it looks like it just stops right here at -1, but really there's that asymptote, and we know that. So make sure that you show that. The asymptote on this would be x equals -1, and the domain would be from -1 to infinity, and the range would be all real numbers. Okay, now for exponential functions, these have the horizontal asymptotes, and you get that from right here. So that's the first thing I'm going to do on this one, is draw my horizontal asymptote. So my asymptote on this is y equals -3. And then I'm going to plot some points. And once again, you can use your calculator to get these points, or you can just do them in your head. It's up to you. So my first point that I'm going to plot is, let's see, probably -1, 1 would work here. And -2, 9. And I can go ahead and do 1, -2.5. So it comes up and then it comes down and gets closer and closer and closer to this asymptote. And I want you to show that. I want you to show that asymptote, and I want you to show it getting closer and closer and closer. Okay, so the domain for this, now the range on the logarithmics was all real numbers. The domain on exponentials is all real numbers. And the range would be from -3 to infinity. All right, let's go ahead and do this other one. There's no number out here, so your asymptote's at 0. And plot some more points really quick. First one that I'm going to plot is 2, 1.8. And then 3, 5.4. 0 is 0.2. Looks like that's all of them that are going to fit on this graph. So come in, it gets really, really close, comes up, goes up like that. Once again, if you just hit graph on your calculator, it looks like it stops. It does not stop. It just keeps getting closer and closer and closer to that asymptote. So the asymptote on this one would be y equals 0. Domain is all real numbers. And range would be from 0 to infinity. All right, let's look at question 18. Exponential growth. Remember, that means that both the A and the B are positive. So this one's positive or not positive, I'm sorry. This is positive, and we're looking for a B that's greater than 1. So positive, greater than 1, so it'd be C. What's the horizontal asymptote on number 19? We're just looking at this number right here, so y equals -1. So you really need to be familiar with those asymptotes and the basic shapes of these graphs, and you need to know how to plot points and what the end behavior should look like.